Now I'm going to talk how to convert the pH into the mole per liter form, the interconverting. Now we pull up a calculator. You can see in this number mole per liter. How are you going to change to pH? So first, you're using the highlighted log key, bracket the number. Then, that's what you should put in, minus log 0.00123 equal. That's the answer. So now you convert the mole per liter form into a pH form. The next question. Can you convert the pH back into mole per liter form? Yes. Say pH 2.9 means 10 to the power of minus 2.9. Same thing. So you put 10 and using the key that I highlight and minus 2.9 equal. Here's the answer. So now you convert the pH back into mole per liter form. So pH and mole per liter are convertible. They can one change into the other. Let's do an example. I want it into pH. How do you do it? Put onto calculator. Some students, maybe they're not very good on mathematics, so they please aware of this 10 to the minus 3, power of minus 3. How did you put onto calculator? That this way. So now you can key that in. And here the answer. Let's do some exercise. Can you convert mole per liter into pH? First question. What will be the answer by calculator? Second question. Careful. This is a dipotic. Dipotic, that means each molecule will give 2 H+. Last question, each molecule give 1 H+. So if 2 H+, you have to times 2. So that is the answer. Remember, if the molecule is a dipotic molecule, you will give 2 H+ ion. Student, always refresh yourself. What is pH? pH measurement is the concentration of the H+ ion, not the molecule. The H+ ion concentration. Now, question 3. I want to do reverse. I give you pH. I want it into mole per liter form. Can you do it? Next question. Next. Now we learn the pH. We're going to see this acid in solution, how I'm going to dilute it and to neutralize it. Start. Now let's look onto a picture. If I compare these two pictures, they both are dilute acid and they both are a strong acid as they are fully ionized. But seems they are something different. They both have 4 particles, 4 acid molecules. But how come when you count the black dot, one side you have 4 dots, but the other side, how many dots? You have 8 dots. How come they different? Reason. This one is a monoprotic. Each molecule, each acid molecule give 1 H+. Each acid molecule give 1 H+. And this one is a diprotic. Diprotic. Each molecule give 2 H+. Each acid molecule give 2 H+. So you will give more H+. That means you will have a higher concentration of H+ ion. So it will affecting the pH. So you can see the strong acid and the strong acid, if they are a monoprotic, one molecule of acid give 1 H+. So the concentration of the acid molecule always equal to the concentration of the H+ ion. The molecule relationship and the H+ ion relationship will be equal. As if I have 0.123 mole per liter, H+ ion will be the same. And now you can convert mole per liter into pH form by using calculator. Next, a strong acid, if you are diprotic, you will find the concentration of the acid molecule and the concentration of H+ ion, you have to be double on H+. So H+ times 2. So each molecule give 2 H+ ion. So imagine if the concentration of acid molecule is 0.123 mole per liter, the H+ ion concentration going to be 1.123 times 2. So it will be double. And once you times, you also can convert to pH. Then how about weak acid? Weak acid, the acid molecule of concentration on the H+ ion concentration will be different. As in this here, you have 4 particles, but 4 acid particles, but only 1 ionized. So you cannot give this relationship. Keep this in mind. Dilution. Year 11, you have already learned dilution. As a particles dilute, when you add more water, What's equation? C1V1 give C2V2. As example, C1V1 C2 was V2. How did you calculate? As this way. Now, I'm going to talk about the H plus ion dilution. Instead of calculating the particle dilution, I'm going to diluting the H plus ion by add more water. It's going to be identically same principle. So, it will be pH 1 into 5 liter and in pH 2 to how many liter? Oh, how to do it? Remember, pH you have to convert into mole per liter form to do calculation. This pH 1, 2 is good, easy to compare, but you cannot do calculation. You want to do calculation of it, you must convert back into mole per liter form as by using the calculator. Now it become, once you're using calculator, you convert it back into mole per liter form. Now you can do the calculation as follows. That's the normal way you do dilution. Let's try a dilution question. Read the question. What's V1? Add. What's V2? So on equation, V2 should be here's the answer. Now let's practice more on diluting. Question 1. Read. Question 2. Neutralizing. When you put an acid neutralize with a base, sometimes they are not fully neutralized. As in this example, you will find that is still left over, they are not fully neutralized. My question is, what is the pH? Other word, what is the concentration of H plus ion now after this neutralizing? Now I teach you how to do it. Let's look at question. Read the question. First, you have that much HCl, that much NaOH. You neutralize, but there is some excess H+. 3 steps. Step 1. Equation. 2. Here, so you know how many mole. So that means you put how many mole of HCl in. Step 2. You put how many mole of NaOH in. Then, once you work to mole, mole minus mole, the plus minus the minus. So, what you end up is going to be the excess. And this is the excess H plus ion. Step 2. This H plus ion divide 0.05. What is 0.05? C equal N over V. Where's the V? What is the volume? The volume is you have that much volume plus that much volume, and these two volumes add together give you the total volume. So volume, this volume plus this volume give you the final volume. So now you have the N over V. So you're on mole per liter. What's earlier? Earlier you're on mole. Now you're on mole per liter. Remember, pH is to calculating mole per liter, not mole. Once you're on mole per liter, what is the pH? Use your calculator, convert using the minus log from way